A clear, calm night can turn a quiet valley into a bowl of cloud by sunrise. Valley fog forms when the ground cools quickly, nearby air cools with it, and cold, dense air drains downhill into low ground. If there is enough moisture, that cold pool can become saturated and fog appears close to the surface. The first step is radiative cooling. After sunset, the ground loses heat by sending long-wave radiation upward. Clouds can slow that heat loss, but under clear skies, the ground cools fast. The thin layer of air touching the ground, called the boundary layer, cools as well. On hillsides and mountain slopes, that chilled air becomes denser than the warmer air around it. Because dense air sinks, it begins to slide downhill under gravity. This downslope movement is called drainage flow, or a katabatic wind. It is usually gentle, but over several hours, it can move a lot of cold air into the lowest parts of the landscape. Valleys, gorges, river corridors and basins are natural collection points. Once cold air gathers there, it can sit like water in a bucket. Nearby slopes may stay clearer because the cold air keeps draining away from them and collecting below. That is why fog can fill a valley while ridges above it sit in clean air. The next ingredient is moisture. Air always contains some water vapor, but it can only hold so much at a given temperature. As the air cools, the amount of water vapor it can hold drops. When the air temperature reaches the dew point, the air is saturated. Water vapor then condenses onto tiny particles such as dust, smoke, pollen, or salt. Those microscopic droplets are what we see as fog. Moist ground, recent rainfall, dew on grass and nearby rivers all help by adding water vapor to the air. In a river valley, cool air sitting over warmer water can gain extra moisture through the night. If a shallow layer of moist air has already moved into the valley, the cooling process has even more to work with. A temperature inversion helps keep the fog in place. Normally, air gets colder with height. In an inversion, warmer air sits above colder air near the ground, acting like a lid. That lid limits mixing, so the cold, moist pool cannot easily rise and disperse. Light winds help the inversion survive. Stronger winds usually stir the air, break up the cold pool, and make fog less likely. Topography is the reason some spots fog up again and again. Narrow valleys can channel cold air, while broad basins can store it. Small changes in cloud cover, wind, soil moisture, or local terrain can decide whether a morning brings light mist, patchy fog, or a dense whiteout. Across parts of the Great Dividing Range, sheltered valleys often become colder than exposed ridges overnight. For drivers, the key danger is how quickly visibility can change. Fog is often thickest near bridges, dips, creek lines and river crossings. If you meet fog on the road, slow down, use low-beam headlights, leave extra space and avoid sudden braking. Do not use high beam because it reflects off droplets and makes glare worse. Forecasters look for the same ingredients: clear skies, light winds, falling temperatures, a small temperature to dew point gap, local moisture and terrain that can trap cold air. When those pieces line up, a valley can quietly build its own shallow cloud before dawn. So valley fog is not random. It is the result of cooling, drainage flow, moisture, tiny particles and a lid of warmer air above. Learn the pattern, and those misty mornings make a lot more sense.